All right, welcome everybody to the Pix4D Mapper presentation and demonstration. So just a little background on this. This comes from what we teach at our drone camp each year down in Monterey at CSU Monterey Bay. Most of the steps through that are included in a hands-on workshop, but I realized that giving or providing a tutorial like this with a demonstration of how you would walk through all of the data that you might yourself collect in the field and to create an output, that a number of people would like to have an easily referenced video for that. And with the note that whatever data set you collect, the same steps would apply. In fact, I'm using a more complex type of data set than would be than what you might be using. Like say if you collected data with an RGB camera, then that would be a little bit different. With that, I will bring up Pix4D Mapper and show you what we're going to, the whole workflow using a multispectral data set from our Lynn Cove Research and Extension Center. The acronym for that will be LREC. We'll be seeing that in the data. And with that, let me bring up Pix4D. So for all of you, if you are doing this on your own computer, you might have a Pix4D Mapper icon on your desktop, or you might need to search for it to bring up Pix4D, which is what I'm going to do. We'll be working with version 4.90 today, just for reference. So the thing with this is that over time, this will change a little bit, but I just watched some videos of a presentation I gave 4 years ago, and there's been very little functional change in the GUI of Pix4D. It's just differences in the background of how some things process. So the workflow that you'll see here will probably be lasting. When you first open up Pix4D Mapper, you'll see across the screen here. So what you'll see across here are a new project option. To create a new project is what we'll be doing today. Well, you can open an existing project, or if this isn't your first time working with it, you'll see the 4 most recent projects you've worked on. Also, just so you know, there's a video academy down below with all kinds of videos, ranging from how to start a project to how to interpret a quality report. And what I'll be going over today is a condensed version of a bunch of those different videos, and also kind of supplemented with things that I've learned myself, sometimes the hard way. So today we will be working with the new project function. Clicking on that. Automatically, it's trying to point my project to the last project I was opening or working with, which is a Mediterranean oak borer project. But instead, today, I already have a folder on my C drive called Pix4D Exercise, where I can point this project to. If I wanted to keep that as the default location, I would check that use as default location. That's what happened with that Mediterranean oak borer project that I had before, because I was doing multiple projects in that same location. When you create a Pix4D project, you want to usually incorporate metadata into your naming conventions, is what I recommend at least. And when you have a whole bunch of projects, this helps you to be able to sort out what data set what project you're looking at, and what would be the kind of the underlying data and products for that. And conventionally, I've decided I like to include Pix4D as the beginning of the line, just to differentiate it from, say, data folders or other folders, projects that you'd be working with in your directory, and then use a name that's intuitive. In this case, this would be 2023-09-06. And the location, LREC, I mentioned this before, Lynn Cove Research and Extension Center, _, and then you can go on to even more metadata. I'm not going to get too many I don't want to make this too long because Pix4D will only allow the entire path of anything in your project to get up to 256 characters. If any of your files go beyond that, then your project won't work later on. And this normally isn't an issue if you're working somewhere higher in your drives, like your C drive. But if you are working, like say, on a work computer that you're using, like your username and then your documents and then another level and another level, every one of those file levels adds more characters, and it's easy to run out of spaces eventually. So in this case, it's LREC. I'm going to say MS for multispectral. And I might include something like the altitude of the project, which was 390 feet. So that's 10 feet below the legal limit that you can fly above ground level. So whatever project you're using, you can adopt a file naming convention like this, but find something standardized, and I prefer to have the year date at the beginning so it sorts over time well if you are doing multiple projects at the same location. You also might include a timestamp like 1,300 hours or something after that. With that, I would leave the rest of these unchecked for right now. I virtually never do project merging anymore. These other options, it becomes a hassle. It doesn't give me the best results. From there, I just click next. And this is where you would add in photos. For this project, I have these photos in a data folder, specifically 300 images. And there's a couple of ways that you can add this data in. I prefer to take them from the Windows file directory option. So the little file folder are usually on the bottom of your screen. Or you can also add data from inside of here by clicking add images and then going to your file folders. The reason I like to do it from my file directory in Windows is that sometimes I'll have a whole bunch of different file folders that I want to put images into a project. And it's often easier just to click on the first image, Control A, and then drag and drop them over, and then go up and move into another file folder and then do the same and drop it in. And so it's just a slight time-saving methodology. One thing you do need to make sure you do, though, is to ensure that your count goes up on your select images pane each time you add the images in there, because sometimes it's easy to control all and then accidentally drop them outside of the select images. Good. Once these are all in, we click next, and it'll take just a second for it to come up. And this is going to be your image properties pane. What we are working with today is Altum data, and that's a multispectral and thermal camera. And in this case, I removed the thermal imagery just that'd just be extra, and it confused the workflow a little bit. But with this, I've got a blue band, a green band, a red band, a near infrared, and a red edge band. Bands are, in the case of this camera, refer to actually 5 cameras built into what you call, like, say, one camera. So they each snap at the same time. They're separate collections, but they instantaneously collect their pictures at the same time. And each one of these, in this case, image 94, because that's the position of the blue camera shot. Then 94.2 would be the green, 3 would be red, 4 near infrared, and 5 would be the red edge. You see that across the bottom of the screen. If I scroll down, you'll see that then the count goes up with 5 pictures intervals. So 97, 97 until you get up to 98. And we'll come back to why that's important to know that or recognize that later on when we're doing our georeferencing steps. If you needed to, you could disable some of these images, but we'll also return to that later on. Something that's valuable to do, especially if you're going to be using your data in GIS, is to save all of these latitude and longitude positions into a file, including your altitude, so it can be overlaid in your GIS, and you can use that for clipping and other purposes of display. So how we do that is we go up to File and click on this, and then browse to a folder location that we'd want to put it in. In this case, this is our Pix4D project folder. I might even click on this a couple times and Control C to take that name, and then go inside of the project folder, Control V, and say something like photo points. What this does then is save a CSV file into the project that then you can open up in GIS and then see all these picture points on your project. Good. Once that has been done, you'd click Next. What you'll see is a select output coordinate system. I highly recommend that you just go with the default. You're only going to get yourself into trouble with switching this around, and you can always reproject your data in your GIS project later. You need to conform your imagery to something else. So going with the standardized universal transverse Mercator, in this case, zone 11, I would recommend that. And then next. What we see here are, and you won't see these two personal ones, I'll show you how to create those shortly. You'll see standard processing templates. By far and away, the most common one is probably going to be the 3D maps. With this given template, can I extend this down further? I guess I have to scroll. With this, what you'll produce in your outputs is an orthomosaic. So that an orthomosaic, if you're not familiar with a lot of these terms that I'm throwing out here, just put it in the chat and someone will be able to answer. But for example, DSM stands for digital surface model, or the top of the canopy model, if there's canopy on your landscape. But I digress. The orthomosaic is a geo-positioned and corrected image. So imagine when you take your phone and you want to collect like a landscape picture, and you take a whole bunch of pictures in a row and then it stitches them together. An orthomosaic is a little bit like that, but extraordinarily more rigorously processed. So each position in it should be pulled up to pretty close to its correct horizontal or latitudinal position. And so it's ideal for mapping. And that's part of the stitching process, is taking away panoramic distortion and pulling it into its correct geopositioning for almost every pixel. Besides that, I mentioned digital surface model. The 3D mesh and point cloud 3D meshes is essentially taking your imagery and wrapping it around a point cloud that's generated during the processing. And some of these functions can also be incorporated into other templates, like your 3D model with your advanced settings once you get into the selecting your processing options later on. So I mentioned 3D maps, the most common. 3D models is probably the next most common for 3D visualization. And then the ag multispectral, I never use that because, again, I can adjust the settings in my 3D maps to include all of these things, like a normalized difference vegetation index or normalized difference red edge, that sort of thing. So you can do all those functions in your 3D maps in your processing options. Below that, then you have your rapid options, which process about 16 times faster than the above options. These are good. They do in kind of more or less the same thing as above, but just not as well, but faster. The value of this is if you're in the field and you collect data and you want to spot check to make sure that it is good before you go home. For example, sometimes I go on long trips, even internationally, and I need to know that my data is going to process before I go home. I will at least process it with the 3D maps rapid processing, just to make sure that the imagery does stitch together okay. And because if it works in here, it'll definitely work in the more robust standard processing. Besides that, the processing steps are all the same. The only one of these besides those that I should probably mention is the thermal camera option. That adjusts some of the matching options to be a little more optimal for thermal imagery, because the process of photogrammetry, which I'm not going to get into too much here today, is it every well, thermal imagery is essentially a rounded edge on everything. That's the nature of thermal emission from objects. And it decreases contrast points, which makes it harder for software like this to process. So it has different matching options that work a little bit better. With that said, what we'll do today is just click on the 3D maps and do not, I repeat, do not click the radio box or start processing now. You don't want that, or you have to stop it later and it takes time. But after that, I'll say finish, clicking finish at the bottom. So here's the 300 images. You'll note that there's not 300 points. There's actually 1/5 that, because each one of these points is 5 images in the same position. And just to give a little overview of the options across the top, as well as along the side, the tabs on the top, starting with project, you will have what you would expect: open, close, project, save, that sort of thing. Next over, you'll see process. The thing is we haven't done processing yet that will enable a lot of these next processing steps to occur. So they're all grayed out right now. Also, I might note that under process, most of the processing options are also included across the top here. So I don't usually have to go to most of these. The one I do often need to go to, though, is quality report, is to generate a new quality report if I make changes in my project. View, this is also redundantly included across the left side of the screen, you'll notice, so I don't really need to go into here almost ever. Map view, this is something that's useful for minimizing your extra processing and the product area. And what I mean by that is if I zoom in on these points here and I want to just limit my processing to the footprint of my imagery, I might click on this, select processing area, and draw. And with that, I can go around from the corners. Oops, if I click on one of the images, it's going to snap to it. I can left click around this just to process the footprint. Then I right click to close my polygon. This is actually just a time saver when it comes to doing the same thing in, say, ArcGIS Pro at a later time, because then your products will already have a nice clean edge. And what I mean by that is each one of these photos are going to have the footprint of the image is going to be fairly larger than it could be a box area that could extend out, covering up several of the other images, including well outside of the footprint of the flight. But something to note is that anything that's outside of this area, under that is the images, the nadir positions below all of the images, is going to have spectral and spatial distortions, because you're only going to be seeing those positions at an angle in the panoramic distorted area from the footprint. Think fisheye, the fisheye area of these outside edge images. So that's why you might set your limiting area. For now, I'll just remove that. I don't need that on there. Something to look for here is to make sure that your images are actually where they should be. So if you have a background image like this, very Google Earth-esque, you can see that I flew in a lawnmower style pattern and there's no major gaps in the imagery. Sometimes you'll see that with a lot of cameras. Say the drone is flying too fast and the camera can't write the images to the card quick enough. It will jam up the camera occasionally. Sometimes it'll also just, for some unknown reason, just drop images. And so they're not included in here. And so you might want to look at this before you go home and want to process your data, just to verify the positions of your imagery. Good. Moving on. Help also is available here. You can go to online support, similar to at the very opening screen where there was options for the tutorials. You can find that through help support and those kinds of things. I sometimes go to the about just to check versioning. That's important. If you're publishing something, you might want that information. Now moving across the next row of icons, we have the image properties editor. This can bring you back to the images that we already looked at the very beginning. This is in case, say, you wanted to disable all of the first position camera. And then you'd need to uncheck all the 94s. I'm going to cancel that for now. The reason for this is sometimes you might launch your flight from a distance off and you'll have a string of images running up to the edge of your flight area, the area of interest, and you don't need to process those. It'll just create a strange, like just a string of images to the side. You might want to disable those images, just not to clutter up the project. Next over is the GCP manager. So that's short for ground control point manager or manual tie point manager, MTP. We'll return to that in a little bit. You'll see how that works. There's a quality report option, which we'll look at in a moment. And then we have the open folder results. We'll also return to that shortly. And when I show you how Pix4D automatically organizes its products, which is not really ideal in my book, but it is what it is. It'd be nice if it was a little bit, they output their data in a little bit more organized fashion, more intuitive fashion. The next two of these are the re-optimize and rematch and optimize. Those are for when you put in ground control points, is one of the next steps we're going to do as well. After you put in ground control points, using the first tool, you would use one of the two of these to reposition your image products to be exactly where they should be spatially. Finally, we have the zoom in and zoom out. But if you're working with Pix4D, I really, really highly recommend that you have a mouse or a trackball so you can scroll around instead of having to use those clumsy kind of functions. Last but not least, we see across the left side, you'll have a variety of options, but what I'll cover today are really just the map view is what we're looking at right now, and the ray cloud. And the ray cloud is where you do your ground control points, and it'll show all of the 2D points or 3D points that your imagery it uses to match themselves together. That'll make more sense also when I close this project out and would reopen it. Across the bottom, we'll see processing steps. So the way it organizes itself here is in 3 processing steps, and really it could be just 2 because you often do your initial processing and then you'll run the next 2, virtually always run the next 2 at the same time. You'll just run number 1, do some more work, and then run 2 and 3. You'll get log output, which we won't worry about right now, but under processing, if I click the processing options button at the bottom, it'll bring up those 3 initial processing, point cloud and mesh, orthomosaic, and index options across the left, as well as a resource notifications. Starting at the top one, oh, by the way, if this is your first time, it isn't mine, of course, so my advanced button is already checked. I would recommend clicking the advanced button at the very bottom left-hand corner of this window. So then you'll have not just your general tab under initial processing, but also the matching options. The reason why this is important is sometimes when you are processing imagery, it won't work out so well. And if you click on the free flight and terrestrial, that will very often solve the problem, particularly in areas that have a lot of relief or on a steep slope. And relief, like from, say, the top of a tree to the ground, the free flight and terrestrial will, the processing will match your images better that way. By default, the aerial grid and corridor is good. That, in theory, gives you a better horizontal positioning of your image products rather than the free flight or terrestrial. But it doesn't always work better. Finally, calibration. There's a variety of options here that we don't really have to get into too much. Almost the only times I've ever had to adjust this is with thermal imagery, because thermal imagery can be kind of finicky. And with that kind of imagery, I will often switch to alternative and adjust the parameters to leading or all prior to get that thermal imagery to process a little bit better. So from here, the defaults will be fine for today. Moving to the next option, number two, point cloud and mesh. This will produce files that you don't really need most of the time, at least working in GIS. And an example of that is an LAS file or light detection and ranging file. It's the last file is what LiDAR systems produce. It's essentially a XYZ point cloud of positions. And that file can be rather large, and we don't use it usually. But what we do like to do is classify the point cloud. This improves the final or the product of a digital terrain model or a DTM. That is subtracting anything that the software algorithm determines is above ground. Say if you have a tree and based upon the angles of the point cloud, it removes objects that would in theory be unnaturally wouldn't be surface level. The 3D textured mesh, unless you're going to put this into some kind of software like 3D Unity or some kind of a web browser where you're going to look at it in 3D fashion, you probably don't need to export these 3D mesh files either, at least from a GIS standpoint. And then advanced, just leaving that default is fine. I'm not going to go into the DSM and orthomosaic index options right now because I want to come back to it because it fits a little bit better with what we would do right before we finish the project. Lastly, though, I will refer to the resources and notifications. Something to know is if you're working with a significant amount of data and you leave it at the default of using up all of your RAM and all of your CPU threads, it'll suck up all of the abilities of your computer to the point where you might not be able to do more than just get on a web browser. Say if you want to work on something else, you might need to turn these down a little bit to be able to even bring up Excel, for example. So just you want to know that. Otherwise, if you try to bring something else, it'll sometimes jam things up. Also, if you want to run two projects, say overnight, what you might want to do is take this down to half. So say 32 and 10. And you can then start one project and then start another project and run them at the same time. And you get back the next morning and you have two projects that have ran overnight. Because some projects will take a long time if you have a lot of data that you put in. I mean, as in many hours. If you're working with an organizational account, I wouldn't check this send notifications when the processing is done. In our case, we're working with an UCANR-IGIS classroom account. And if I check this, then my colleague Shane Fire gets an email when my processing is done because he's the account manager. Good. With that said, I'll come back to the digital surface model and index functions and the templates here once I've got done with this. Next step. So once those settings have been set up the way that you like them, you would uncheck these next two options and you would click start. The problem is this first step, and I have a really fast computer and it still takes like 5 to 10 minutes to run a project this big. Might take another computer an hour. So I've already pre-processed this through step one. And so what I'll do is I'll just shut this down and discard my changes. And I'll go into my file folders, into my Pix4D exercise files, go to Pix4D, which are my projects, And if I stretch this over, you'll see that I have processed through step 1 and I've processed through step 3. So we can see what I'm doing and then how it turns out. So if I would have clicked on start and now I bring this up, then we will see what the output would be. So then we could include our ground control points in the processing. Let's just take a moment. Oh, if you ever move data from one computer to another, then the pathways to the data get interrupted. And to fix that, you'll get this notification. I would click OK. And I just have to go up a level into my directory and point the Pix4D project at my data folder and select folder, and then it'll load up fine. Good. So now what I would do, the first thing I'd usually do is when I get data in like this, I would go and look at the quality report. And that now is an option. Remember, before it was grayed out and I couldn't see it. So I would click on that. And the reason for that is that if the imagery is not going to stitch together well, you'll usually or almost always get an indication in your quality report right off the bat. And in the quality report, just a note, if you click here, this will bring you to Pix4D's description and a video of how to assess your quality report. This video includes a lot more than that. They used to have a more concise video, which I kind of liked a little bit more, but it still gives you the information that you might need for this. But back to my quality report. The first thing I usually look for is what my ground sample distance is. And that's essentially your average spatial resolution in centimeters and inches. In this case, we have our imagery's about 2.1 inches on the ground, each pixel. If I go down further, you'll see the area covered. It's important to know this is not actually the area covered. This is including the extra kind of splash of the imagery beyond the footprint of your flight area. I would much prefer if the area covered only reported right underneath your flight lines, but that's just the way it goes. Next, we look down and we'll see a quality check. Usually you want the first 4 of these to be green. In this case, we had 15 images are really 5 images times 3. So there's 3 images that there was some problem with them. The camera was maybe the wind gusted and the camera was turned a little bit of an angle to the side too much and an off nadir, kind of a oblique angle to the ground. Something like that could have happened. Could be a number of things. The image might not be calibrated. So the software automatically detected that and knew to disable them. So that's not bad. Only 3 images. Or 5 images, not a big deal. Moving down, we'll see camera optimization is fine. Matching is fine. This georeferencing will always be an exclamation mark at this stage in the processing because we haven't added ground control points yet. Next, I would look at my imagery. And on the right, we have the digital surface model. And across the bottom, you can see each of the spectral bands, the blue, green, red, near infrared, and red edge. And what I would usually do is click on one of these and then click on them again, and then move around to make sure that there aren't any real weird aberrations. And what I mean by weird, see, in this case, there's this line, like an aberration across here. That's not a concern because that's actually outside of the footprint of my flight. And that's what I was talking about, where you get spatial and spectral distortion outside of underneath your flight. But in the footprint, which is essentially from these buildings moving down to past this field, I don't see anything that's of concern. Sometimes you'll see holes or gaps, and in which case you would probably need to go back to your processing and your processing options. Go to your initial processing, go to your matching, and then change it perhaps to your free flight or terrestrial. if you saw something like that, and then rerun step one to make sure that, and then hopefully you would get a better result. Go back. And again, I could do the same thing with my digital surface model. It's going to be kind of clumpy here, but you'll see that it's okay. It doesn't have any real nasty jagged lines or anything that look strange. Like, see along the bottom, you get almost like a watershed effect on the edge. If I saw something like that in the center of the imagery, then that would be something of concern. But this looks fine. As for the rest of the quality report, if I move down, you'll see this initial image positions. And then we'll see a computed image and GCP manual tie point positions. In here, what we're looking at are, in blue, the telemetry data that was geotagged to each image that was collected. And then the green is the optimized position that the software thought that the camera was really actually taking the image from. And the way it calculates this is the relative positioning of the images to all the rest of the images in the footprint that they see. And I'll show you how that works in a moment. So you'll see for vertical and on the right, we have horizontal ellipsoids that show the potential error. And on the bottom, we have vertical ellipsoids for uncertainty. There's an overlap map, which is fine, but actually, if you zoom much further down, this is more important. You can skip most of those. If you go far enough down, this is much better because it shows how many images are actually matching. So each one of these images here, so the lightest lines are 25 images. And then the darkest ones, we have some images have 2,000 matches with the adjacent photos around them. And besides that, if you had ground control points, you would end up having an actual RMS error that would be included down here, specifically if you had checkpoints, which are the optimal way of doing that. I can point you to where you could set those at, but we won't do that today. RMS error is like the standard deviation of spatial error. The rest of this, you can refer to that link at the top, because I could spend another 5-10 minutes on this, and I don't want to, I want to get to the last steps of the processing before that. So I'll close the quality report. Again, that would be the first thing that I would look at. And next, I would add in ground control points to lock my imagery together. What I would do before that is go to the ray cloud. The ray cloud is the 2D points or 3D points that are matching these imagery together. When I said that I would come back to how it re-engineers the positions, being the difference between the blue and the green point. And this is how. If I click on this, the software sometimes, at a minimum, you have probably 10,000 ground control or 2D key points to lock the images together. Sometimes I've seen over 100 million before that'll be used. Well, the relative geometry of all of this point to this point to this point is calculated within the software. And based on that, those geometry calculations is how the software determines that this blue point really should be shifted a little bit to the side based on the angle of the pictures to the ground relative to all the rest of them. Good. Those will show up across then on your layers on your right side. If I turn those off, turn off the cameras and turn off the rays, then we'll just see the sparse point cloud on the ground. I can go up to the navigation tools now across the top that have become available. And specifically, I like the trackball option because then I can just click and drag and turn this so it's facing straight down. By the way, the red is the north-south line. The green is the east-west, and the bluish purple is the level plane. Now, if I zoom in and I add in my ground control points, I can see where they land within the point cloud. And I'll do that right now. It's the second option across the top where it says GCP MTP Manager. I'll click on that, and I'll import my ground control points. By the way, I'll just bring up the ground control points because this might matter to some people that end up doing this in the field. This is a CSV file. I'll open it in Excel just so you can see what it looks like. It's pretty simple. It's comment. The comment is the number of the ground control point. The X, this being a universal transverse indicator, the X being the easting position in meters, and then the Y is the northing meters from the equator, and the Z is the altitude above mean sea level in meters as well. So this is the format that you need to bring in ground control points. It doesn't accept something like latitude and longitude. So what I'll do is import those GCPs now, browse. I'll go to the GCPs and import that file in. And okay. Then I'll click OK again, and then you'll see these points show up, these little blue points on your scene. You might barely be able to see them on your window, but where my cursor's at, there's 1, 2, 3, 4. And how I expand those is on the left side under layers. I have this little pointer, this little kind of triangle pointer. I click on that. And now if I click on the first one of those, you'll see it highlight on the screen here. And then you'll see a GCP manager pop up on the right-hand side of your screen. So that's for ground control point 1. The selection box now pushes this down. This is something I don't like about the new versioning. They made this selection box like push the image down. So you need to reduce it. Oh, someone, can you mute your computer? Good. So now in here, we have now 135, 135, but these are all from the same positions. I mentioned earlier that it's important that we recognize that the position in the camera number 1 and 2 and 3 are all taken from the same place. We want to optimize the positioning of these points, so we need more than one position to lock to. How I do that is I scroll in on this, left click to add a circle. By the way, if you accidentally put something somewhere where you don't want it, you can hover over it and click the delete button on your computer, and I'll add it back again. And next, I would not go down and add another point on number 2 or 3 or 4. I would go to a whole different number. What I can do is scroll this down so it's almost to the bottom, and then I can click down images till I get to, say, 134. Might even go to another band, and then add in. The directions would call for doing this same process for at least 4 positions. I recommend more like 5. You'll see a green spot appear once you've added in a couple of these ground control points. So what we're looking at here is a target that I laid out on the ground, and then I recorded that position with our Trimble, and then used that Trimble data to create the table that you saw before. So then matching this to the coordinates that would be seen in the selection, these specific coordinates, that is how the processing knows to shift the imagery to be matching up to those known positions. I won't do this for too many images, but I will show you another little trick that you can do. Sometimes it's hard to find your image within your not your image, your ground control point, your target on the ground. And if you want to hunt for it, you can always hover over the image, click the space bar, and then you can zoom in and find your positions easier because you have a lot more screen space to work with. And then you press the space bar again to reduce it back. Another thing that you can do that's handy is that there's up at the top right-hand corner, there's this little focus on selected. Once you have your green points where you pretty close to where you want, you can click on that, and then each of your images after that will be centered on your targets. Note that if this position is way off, say it's consistently, it might be here, it might be there. If it isn't really close to the center of your target, you'll want to collect a lot more, as in like almost as many as you can get, say 10, 20 points instead of 5. And when you're done, you would go up and use the rematch and optimize at the top left-hand corner of the screen, like the sixth icon over, as opposed to reoptimize. Rematch and reoptimize is a more intensive process of rematching the images together yet again that was done in stage 1, and then reoptimizing them at the same time to those positions. It just takes a lot longer. Usually it's not needed, but it might be needed if you have, like, again, your green spot's off of its mark here. Once I've done this, I've got enough of them in. I would expand the selected, and you can see I have marked 5 images here. I would select apply. And then oh, good. And then you'll see over on the left, 5 is now included in the parentheses. So you know that you have enough positions on that one. You might do the same thing for the next number 2, 3, and 4, but I'm not going to do that for time saving's sake. You don't need to watch me work when we're getting close to the end. Once you have done this, and assuming that that you don't have a significant error of, say, your points are way off of where you expect them to be, as soon as I add, say, 2 of them in here, then after that point, I would go up, click on reoptimize at the top. The errors were bad, rematch and reoptimize, but if not, reoptimize. And then you'll get a little box across the bottom that'll show the progress. And when that's done, you would bring up your processing again. You would uncheck the first initial processing that you see is in green now because it's already processed through that. And then you'd process the next 2 steps. Before you do that, this is where I said I would come back to the processing options of the DSM and orthomosaic. I'll click on that now. And inside of here, I'll make sure that everything is set the way I want it. One thing is, if you're working with an RGB image, you would want to click orthomosaic and geotiff without transparency. I don't need an orthomosaic though, because I'm going to be creating reflectance indices of these, so I don't need that checked for multispectral data. Come back to that in a second. I would also click on the next option at the top and highlight geotiff. If it already isn't selected under raster DTM or digital terrain model, I would click geotiff and merged tiles and uncheck any of the other options. And lastly, I would go up to the index calculator. And this is why and I want to emphasize this, if you're doing it with RGB data, you would want to have your orthomosaic and these 2 buttons checked. But being that it's multispectral data, we handle that different. I have all of these checked here, and I'll come back to the calibration. And then I create a reflectance map, geotiff with merged tiles. So blue equals blue, green equals green, and all the way down, including NDVI or normalized difference vegetation index, to create essentially a plant vigor and health layer in your output. Moving back to the top, how that works is inside here, you see there's a calibration process occurring. What I do is I click on calibrate. And in this case, the software recognizes the QR code and automatically places this box on the white panel, and then populates the reflectance factor with what is reported from, in this case, MicaSense, the company that creates the white panels. If you don't have that information and you have the serial number, you can go to MicaSense's website and look up the reflectance values for your given panel. And then you sometimes might have to go on here and click around with your left click and then right click to add in a new box. That occurs sometimes when you have like a shadow that's partially cast across here when you're taking your drone image, say your drone leg is partially over your QR panel or this, and the software can't recognize it and doesn't get it quite right. So you can manually put that in. And then you can also manually add in your reflectance factor. I'll just go with the default on this, but also if you needed to, if the software didn't automatically recognize your panels in your image collection that you put in, you could browse and then go to your file directories and pick your cameras. And remember, blue is 1, green is 2, red, near infrared, and red edge. And each of them will have a slightly different reflectance factor. Good. Once all of this stuff has been set, then we are basically done with our project processing. This is all checked. It looks good. The quality report looked okay. We could save this as a template. In this case, I could click and I could update the standard Altum template is what this is set up as right now, or I could create a new template with the current options. If I clicked on those options and then went over, it would show up under my personal. That also will be available on your next project when you open up that initial processing. If you get settings that you like and you want consistency, then I really highly recommend this for time saving, and also to make sure that you don't accidentally leave some setting off that you want at a later time. But once all of these settings are okay and say your template's saved, I would click OK. I'd make sure that these last two were checked, the redded ones on the bottom of the screen, and I could click start. And once I click start, after about, I don't know, an hour or so, I'm going to close this. I could go back into my Pix4D folder through step 3, and we would have a new quality report that would have a little bit more additional information and will also let us view our data in a little bit more. I still have to redirect to my data again. It'll give us the final process result in our rate cloud. And this is another kind of quality assurance checking option that you can do. So what I did is I brought up through step 3. So if I would have clicked start before, I'd bring up my project. It would look like this. I'm going to go to the rate cloud. And this time I'm going to click on my point cloud and my triangle mesh and uncheck my cameras. In a second, once it gets done, I don't want to jam it up. And if I zoom in and scroll around, you can see that it looks pretty good. There's a couple tie points are kind of hanging out there, but yeah, so you can see now we have a 3D model that we can zoom through. By the way, just so you know, you can also make recordings, and it's specifically nice with RGB imagery. In this case, we're just looking at the green band in black and white, because again, I mentioned earlier, is 5 images simultaneously taken, and you have to composite those together in your GIS, which is what we'll be presenting on next Friday, is how you would take this exact data and work with it in GIS to visualize it and make it look something like this, or like this, with with each of the bands all meshed together or composited together. Good. I know, right at the hour. I went about 5 or 10 minutes longer than I expected it to, but I like to get long-winded on certain things. Do we have any questions? I'm going to bring up my chat, and I'd like to thank all of you for attending today. Hopefully this is what you were looking for. And Andy, I believe Andy will be sending out an evaluation form. If you could please fill that out, I'd really appreciate it. Every time we get good feedback, we work with that, take it seriously, and it also gives a kind of an accounting of what we're doing and the services that we're providing. Shift Alt Leave H, there we go. Good. And I will stop sharing and look at the chat. Good.
Yeah, thanks, Sean. That's great. No chat questions, but if anyone has a question, we could take a couple questions now.
Yeah, you can unmute yourself and ask away. And if you are going to get off, thank you all for coming today and taking this time on this Friday. And just so you know, we have office hours on Mondays and Tuesdays that you can sign up for on the UCANR-IGIS website. You just Google that, you'll be able to find us. And if you get hung up on some step of processing, we're always here to help. Again, thank you all for coming today and hope to see you again soon.